So starting with the bookwork. Now 54 was you're supposed to draw a scatter plot. Like 54 and 56, we're talking about the same problem. See if I can find. I think I had an answer to this. I don't like the wording of the whole answer key, but as far as maybe I don't have it pulled up. Your graph. Why do I not have this one? Oh well. What is the least squared regression line equation for your graph? What does it start with? What does a least squared regression line equation always start with? Y hat. So this is y hat equals, and then what general number always comes first? Your y-intercept, which here was, this might not be rounded all the way, but something like this.
And how do you get that?
So you have all these numbers, so how do you get this? So this would be this is list 1, this is list 2, and then in your calculator you go to what buttons? Not that one, but you go to stat, and then which button? Which number? 8, which is linear regression. And then so it gives you your output. So it gives you a y-intercept of 201.2, and then in general, what goes here? Always your slope. Again, you probably rounded differently than that, which I would hope you would go more than these if you can. And then so that is your least squared regression line equation, which you would then go and draw back on your scatter plot. Explain in words what the slope of the regression line tells us. This is as the what does what?
As the x.
As the x, and what's our x? Mass. As the mass does what? Increases by 1, 4 units here. As your mass increases by 1 kilogram, we predict that the metabolic rate will increase by about 24.026 calories burned for 24 hours. And then I want to make a big point about this because I think y'all be fine about it, but kind of what one word does it ask you in part D that's very, very obvious as to what you do?
Predict.
Anytime it asks you to do this, predict, what is the predicted? We plug it in. And so that's, now there are going to be some things where it's like, oh, well, we predicted this and this happens and that's not the actual question. But almost always in this chapter, if it says the word predict, plug it in. And then so all you do is plug 45 in right here, and you get that y hat equals about 1,283.3 calories per day. All right, 56. Oh, there's my graph that I was looking for everywhere. So your graph should look something similar to that. So 56, this is your residual plot. You should look at this really, really easy. And part B says which point has the largest residual. You should be able to look at that and see that here's my biggest residual, but then you got to kind of figure out what it goes with. So the point that has the largest residual is a residual that's about 200. Well, if our residual is positive, does that mean we over or underestimate? Yeah. That means we underestimated because here's our estimated line. and the estimated line is under where we ended up. So that means we really, really underestimated the metabolic rate for that one person. All right, 62, it gives you this graph, and then it just says, would it be appropriate to use the regression line to predict y from x? Yes or no? What kind of graph is this? What kind title-wise? What do we not want to see in a residual plot?
Pattern.
We do not want to see a pattern. This is a pattern, so is it a good idea to use this to predict? No. And that's all you needed to get out of 62. All right, so like I said, these are really, really, really good multiple choice questions. Typical of what you would see on a test. So figure below scatter plot of reading test scores against their IQs for 14 fifth grade children. The line is least square regression line for predicting reading score from IQ score. If another child in this class has an IQ score of 110, what's the key word there? Now, usually when we said predict means you do what? Plug it in. Well, where's my equation? I don't have it. But can I look at the graph and do the same thing? So I start at 110. And now use a piece of paper to make sure you're actually perpendicular to this. I'm using a feature that only goes literally up and down. And then so I go to here and then follow it over, which is really, really close to 60. So even though I don't have the equation there, I'm doing the equivalent of plugging it in. The slope of the line in the figure above is closest to, which one can we mark out immediately? Look that up.
0.
Honestly, if I didn't give you either of these axes, the numbers on either axis, it could be any of these answers because depending on how it's scaled, because these are going up by 10 and these are going up by 5. So visually that can kind of be a little bit misleading. I think the easiest way to do this one here is go end to end and look at it like no, it's not 150. And use this to figure out what my slope is. So in the x direction, I started out with what? And I went through what? So that is a distance of what? In the y direction, I started where? About where? Somewhere in there. And then ended up at about what? Which is about what is that minus that? So how do I figure out slope? Rise over none, change in y over change in x. It's about a little bit over 2/3. So which of those possible answers is the closest one?
1.
C, which is 1. Smokers don't live as long as non-smokers, and heavy smokers don't live as long as light smokers. You perform a least square regression line on the age at death of male smokers and the number of packs they smoke per day as X. So if they don't smoke very much, what kind of age at death should they probably have? If they smoke a whole bunch, what should their age at death be? And that's all you need to get out of that. So our slope will be what? What kind of slope is that? Negative, so less than 0. This one gives us an equation. 74 is an okay question, but I think it's too easy. How much does height increase on average for each additional centimeter of arm span? What?
0.9.
So this is just asking what?
Slope.
Slope. Because slope is now I've seen a problem like this asked slightly better or slightly higher level. Then what would I do? Slope multiplied by 3. Y'all get the, I mean, you're just applying the slope without like literally looking at the equation itself.
I understand how to do it. I got it right, but I don't know what you just did.
If it asks that instead.
That's x increases by 3, then what do you do? Plug in 3 for the x.
Slope times 3. So like if it asked you as x increased by 3, what would y increase by? It would be 3 times the whatever the slope was. Because here it just said it's x increased by 1. According to the regression line, the predicted height, which means what? Plug it in. So 100 times 0.93 is 93. 93 plus 6.4 gives me what? What?
99.
So you're just plugging it in there. By looking at the least squared regression line equation, you can see that the correlation between height and arm span is, well, this is my what? This is my what?
Slope.
What is this? So R always directly relates to which one of those two things? Slope. And if here we can see that slope is what?
Positive.
Positive, so R is in addition to the least square or to the regression line, the report says that R squared equals 0.95. Well, this just means interpret, like I told you, this is the only thing we're going to deal with R squared. R squared is the percent of what in what? Variation in percent of variation in what? So this one asks us for a what? Residual. Well, what does residual equal? So it says one child in the study had a height of 59. That's our what? That's our observed y. And an arm span of 60. What is this? So our observed is directly 59. I have to find predicted also. How do I find predicted? Plug it in. So we're plugging in our x into that equation, which gives us what? 62.2. And then I just subtract and get what?
And why are you subtracting? Oh, because it's your minus.
And is it bad to have a negative residual? No, that just means we overestimate. Questions on any of this homework? And that should give you an idea of a typical multiple choice kind of questions that go with this.